In this video I'm going to talk about frequency tables and how to represent data visually using different types of graphs. So this first example, we've got some survey data of how many hours people spend online each day for personal use. So these numbers here represent a number of hours online. And there's two different types of frequency tables. The first is a simple frequency table, and in this case we would go through the data values typically in order, so maybe I start with 0, which is the smallest one. And next to the data value I put the frequency, so how many times does 0 occur? Well, there's only one 0 in this data set, so that would just be 1. And then we go to the next highest. I think the next one is 1, and there's only one data value as well, so that would have frequency 1. Next one would be 1.5, and it looks like there's only one of those. And I would keep going here. Now with this particular data set, this is not going to be very interesting because pretty much all of our data values only occur once. It looks like there are 2 7s. So whenever 7 came up here, we would have a frequency of 2. But this kind of frequency table usually is not very good for kind of showing us what our data is looking like. So instead, usually what we'll use is what's called a binned frequency table, or maybe a grouped frequency table. We're going to put the data into classes or bins. So instead of just looking at the data value 0, I'll look at a range of values from 0 up until some amount. Now you can decide how big you want your classes or bins to be. In this case, our data values range between 0 and 10. So I decided to make each class or bin have width 2. Depending upon your data, you might have a width 5, width 10, width 100. You might even want width 1 or even smaller than that, just to group the data into reasonable categories. So when you have a width of 2, that means that your groups are going to be 2 apart. So if the first one starts at 0, the second one will start at 2, 4, 6, 8, and then 10 we can stop. And each of these is going to be a range of numbers. So from 0 until, now you might be tempted to say 0 to 2 here, but then we have a problem, because if the first group is 0 to 2 and the second is 2 to whatever, then when we get to say a data value of 2, it's not clear where to put this. So instead of using the value 2, I'm going to go just less than that. So in this case, I'm going to go from 0 to 1.9 to give a range there, and then from 2 to 3.9, 4 to 5.9, etc. So these are our classes of width 2. And then I'm going to go ahead and do our frequency for each class. And to make this a little bit easier, I'm going to go in order of the data and just put tally marks into the group. So when I look at the number 7, I say, okay, that belongs in this 6 to 7.9 group. I'm going to put a tally mark next to that. When we look at the number 2, that would go into this second bin. 2.5, also the second bin, and so on. So keep going through the data, and then when we get to the end, we'll write our frequencies. Okay, so I've been through all of the data, and now I can see, based on the tally marks, that the frequency of this first class or first bin, there were 3 data values in that category, and then 5, 1, 2, 1, 1. So this is a little bit more helpful than what we saw with the simple frequency table, because we can see where the most people were, which categories the most people were, and also kind of the distribution of these data results. Once you've done a frequency table, for example, I've just copied the frequency table from before on the left here, we can also compute what are called relative frequency and cumulative frequency. Relative frequency is just going to say what is the percentage of the total number of people we looked at. So for example, in the category from 0 to 1.9 hours spent online, there were 3 people. Well, 3 people is great, but 3 people out of how many? I mean, is that a lot of people or not very many? So to do relative frequency, the first thing we would want to know is what's the total number of people? And we can get that by just adding up the frequencies and say, okay, how many were there total? Or you could just count the data values as well. In this case, there are 13 people from the survey here. So when we do our relative frequency, I'm going to say, all right, there were 3 people out of 13. And then we're going to convert this into a percentage. So this first one, if I round to the nearest percent, this is 23%. And go through all of these and do the same. So 5 out of 13, this comes out to 38%, and so on. So this gives us the relative frequency of these different categories. So for example, 8% of people spend between 8 and 9.9 hours online, according to our survey. Now, the sum of your relative frequencies should always come out to 100%. Now, because we're rounding, it won't necessarily be exactly 100, but you can check and make sure that it's pretty close to 100. Maybe this will be 99, maybe 101, depending upon what our rounding was doing. All right, cumulative frequency is taking these same categories but adding up everything that came before. So in the category of less than 2 hours, that would just be these first 3 people. So it's the same as the category before. When we look at less than 4 hours, that's going to be people who have spent 2 to 3.9, as well as the people who were between 0 and 1.9. So this is not just the 5, but also the 3, or a total of 8. Less than 6 hours would be all of those previous 8 people plus the 1 more, so this would be 9. Less than 8 hours would be everybody from 7.9 previous, so that would be 11, adding on 2 more. Less than 10, this would be 12, and it looks like I left out a category here. We'll do less than 12. We had 1 person that spent 10 hours, so we have to add those in, and that would give us a total of 13. So your ending cumulative frequency should always be the total number of people once we get to the bottom there. So frequency tables are a good way to organize your data before you sort of represent it. But typically, if you were writing some sort of statistical report or trying to explain data that you got from a survey or something like that, you would want to do it in a more visual way. So for example, here we have a frequency table for the number of hours of exercise. You can see that these are binned. Notice the gaps here, right? The first bin goes till 2, and then the next one starts up at 3. The data results here would probably be all whole numbers, so we're not going to see a 2.5 or anything like that. Otherwise, we might want to divide it up with some decimals. So we've got the types of or hours of exercise and then the frequency, and we can turn this into our histogram. And a histogram is a bar graph. Along the x-axis here, we see these are the numbers of hours of exercise, and we have them divided up into ranges, 0 to 2, 3 to 5, 6 to 8, etc. These dividing lines should actually be halfway in between. So this one, if we labeled the axis, would be at 2.5, and then 5.5, etc. So we divide up our axis, and then the height of each of the bars along the y-axis says how many people fell into that category, or what was the frequency. So they said that the frequency between 0 and 2 is just 1, so the height of that bar is 1. Frequency between 3 and 5 was 2, so the height of that bar is 2, etc. So this gives us a nice visual representation of our data. We can see that most people fell into this middle range between 6 to 8 and 9 to 11, tapering off on both sides. I'm not going to talk too much about making histograms or their properties, so you should definitely read the chapter on this. But I did want to just show some examples here. So if you go on to Google, I just did a Google image search here for survey results, you'll see countless examples of representing data. You'll notice scrolling through here, there's a lot of pie charts. which are good things for relative frequency or percentages. There's a lot of bar graphs. This would be a bar graph here. Now notice this is a bar graph rather than a histogram because along the x-axis we don't have numbers. This is just categories of things. In this case they have very interested, interested, somewhat interested, not interested. The heights I believe are still frequencies, so this would be a frequency bar graph. So anyway, you might browse around and see what kind of pictures that you can find. Here's another one from D2L. This is from a previous class, but once we have some grades in our class, you could find this in the statistics in the grade book. This was from an exam, and you see this is a little histogram of exam scores. In terms of representing data, you might want to scale something like this down since none of the bars reach 100%. It might make more sense to scale it down a little bit, but you can see, the highest frequency was around, looks like 80, 85, something like that. And we did have, one or two lower scores here, but most were grouped up here. Another really interesting place to look for histograms and things like that is the site OkCupid. So if you haven't heard of them, it's actually a dating site, but they do a lot of really interesting stuff with data. So if you go to their blog, this is blog.okcupid.com, they write articles doing experiments on sort of what people like, what people are looking for when they're going through someone's profile for dating. So this article was talking about what to say when you send a message to someone, what words to use. So this is a bar graph. This is a little different than usual because they're putting the axis not at 0%, but at what the average would be. So these green bars, people who used those words, the percentage of people that responded was higher than average, and then the red bars, the percentage was lower than average. So if you scan through here, you can see different bar graphs like this. Another example that they looked at, this is a scatter plot, so a little bit different way to represent the data. Along the x-axis here is attractiveness, so least attractive to most attractive, and then the y-axis is the number of messages that person received in the last month. So people at the bottom don't get very many messages, people way up at the top get a lot of messages. And you can see that there's some amount of correlation in that more attractive people tend to get more messages, but it doesn't follow linearly. We've got little X's all over the place here. So in this article, one thing they talk about is that according to their data, people in this case, these two women have equal mean amount of attractiveness, but on the left, you see from the little histogram here, most people rated this girl as pretty attractive, not a 5 out of 5, but not on the low side. And in the second case, a lot of people rated her as very unattractive, but then another group rated her as very attractive, so this is sort of a split result. And people who have this split result have a lot more messages than people who just have a higher average. So that's one thing that this article talks about. Before we would finish up, I did want to point out just some ways in which bar graphs and things like that can be misleading, because this is something that's very important to watch out for. This website, statisticsHowTo.com, has a really great discussion of misleading graphs, and I'll link this in the video so you can take a look at the article. So here's a really classic example of misleading graphs. So this is talking about top tax rate now and if the tax cuts expire in these two bars. And it looks like the top tax rate is way higher in the second bar than in the first bar. But if you notice the axis, if you can read this, at the bottom of the axis is 34%, the top is 42%. So because they're not starting the axis at 0, they're really magnifying this gap, whereas really the bars should keep going down. Here's an example of where the actual graph itself is misleading. This is a plot of unemployment rate over time. And if you notice, this second to last dot is at 9%, and then the next one is at 8.6%, but according to the axis, 8.6% should be much further down. Here's a picture of what the graph should look like. Here's another example of a misleading graph. This red line is the average earnings from having a bachelor's degree based on the year, and the blue line is the tuition or cost of a 4-year degree. So there are various issues with this graph, and you can read the article about it, but in particular, the average salary for a bachelor's degree is something that you would keep earning for the whole rest of your life, whereas the average cost of a 4-year degree is only going to be for those 4 years. So the fact that this is higher is not necessarily saying that it isn't worth paying. It just means that it's going to take more than 1 or 2 years to even out the difference. The other problem with this chart is that it doesn't make any mention of earnings without a 4-year degree, so it's hard to determine based on the salary whether this is going to be good or not. An example of a bad pie chart, right? Hopefully if you're reading these numbers you can see why this should not be. Pie charts are always supposed to add up to 100%. So if 70% of people back Palin, that should take up most of this pie chart. So we definitely should have some overlap between these categories. Okay, to finish up, I just have a simple example for you to do just to make a frequency and a relative frequency table for these data values. And I'm suggesting that you use the class width 10. Thanks, see you next time.